Welcome back to the deep dive. Today, we are strapping in for what is probably the fastest, most consequential ride in software development right now.
Absolutely.
The massive acceleration of AI developer tools. We're going beyond, the simple autocomplete. We're looking at the revolutionary product principles driving this breakout success and what the modern agentic workflow actually looks like.
And that speed, it's genuinely remarkable. We have to set the stakes right away. We are witnessing, and this is not an exaggeration, some of the fastest adoption of new tools in the history of computing.
Right.
So the core question we're trying to unpack is, well, it's a bit philosophical, but also very practical. What does having true autonomy, these agents in your developer environment, actually change about the product you're using?
And when we talk about that autonomy, let's nail down what we mean by an agentic workflow.
Right. So when we say agentic, we mean the AI has full autonomy to take a high-level goal, something really complex, like build a data processor for a new API. And it decomposes that goal into smaller, executable steps. And crucially, it executes those steps. It manages the feedback loop from the compiler or the runtime, and it self-corrects without needing you to approve every single command or line of code.
So it's like an AI sitting behind the keyboard, not just suggesting the next word, but running the entire task.
Exactly.
That really sets the scene. And the financial velocity in this space is just, well, it's dizzying. It reinforces that these tools aren't just novelties.
No, they're becoming necessities.
I mean, look at the figures we pulled from the source materials. Cursor's parent company, AnySphere, recently secured a valuation that put it at $9.9 billion.
And that velocity isn't just for the big established players. Bolt.new, a newer company focused on this exact agentic flow, hit $40 million in annual recurring revenue in only 5 months.
5 months? That's not just fast. That growth curve was basically impossible in previous software cycles.
It proves developers are willing to pay for this new paradigm and pay for it instantly.
And Replit Story is maybe the most shocking example of this AI-driven momentum. Their CEO noted that it took them over 300 days just to hit their first million in ARR.
A pretty standard startup grind.
Right. But now, powered by AI, they're adding $1 million every 5 to 6 days, a 19x revenue growth this year alone.
It's just a pure exponential acceleration cycle. And it's not just revenue, it's trust and usage. Warp, which is a terminal built for this new world, sees its users launching almost 3 million agents daily.
3 million a day.
And here's the most astounding number for me. The source material notes a 97% acceptance rate of agent-suggested diffs.
Wow. So developers aren't just trying these tools.
No, they're trusting them. Implicitly, they're committing the AI's suggestions directly into production branches.
It's clear these companies move fast, but, how did they build the right thing? Something that generated that kind of trust and adoption so quickly.
That's the key question.
Let's look at the underlying design philosophy. That market success is driven by a new set of rules. We found 7 product principles that seem to define these modern AI dev tools.
Exactly. And we can group these 7 principles into 3 sort of actionable themes that I think dictate the next 5 years of product development. They are usability, control, and speed.
Okay, let's start with theme A, usability. This idea of reducing friction and starting familiar. What's the first principle?
Start with what developers know. This is critical. The interface has to encourage a seamless transition from workflows they already understand.
So no steep learning curve.
None. Cursor uses the familiar IDE interface. Warp built its success around the terminal, which is, home base for most developers. Bolt uses chat. You have to be able to switch easily, instantly between writing code and just talking to the agent in natural language.
And principle 2, ergonomics. This sounds like it's about micro-optimizations for flow.
Precisely. Focus on developer ergonomics. If you could shave off a single keystroke, you do it, usually with smart keyboard hotkeys or pre-configured actions. The goal is 0 onboarding friction. You're aiming for 5 minutes to WLW.
That's a great phrase.
We've all downloaded a promising tool, looked at the docs, and then just bounced after 10 minutes.
Guilty. These
new tools reverse that. They want you running a fully executed substantive task before you've even had time to register your account. That immediate value is critical.
Okay, let's move on to our second theme, which is control. This is where the philosophy of code really starts to change, right?
It is. This is where the developer's role shifts entirely. And principle 3 is the foundation for that. Chat must be a first-class citizen. We have to recognize that code is Well, it's a contrived representation of human intent.
It's a translation layer.
Exactly. And as these tools evolve, we're moving away from focusing on complex syntax and just communicating the intent itself. You're instructing the agent, not writing the code.
But if the agent is moving that fast, I imagine power users need some serious guardrails and a lot of flexibility.
Which brings us to principle 4, configuration flexibility. It's vital. For the average user, zero setup should be required to see the value. But for the power user, the architect, you need tremendous configurability.
What does it look like in practice?
It means fine-tuning prompts, setting up project-specific rules, and critically being able to swap seamlessly between different models.
So you might use a cheaper, faster model for one task.
Yeah, for a quick refactor. But then you switch to a heavy-duty reasoning model like a GPT-5 or a Claude 4 Opus for complex architectural decisions. The tool has to make that switch instant.
And this theme of control ties into Principle 5, which is about integration, specifically something called MCP. Now, for our listener, that just sounds like jargon.
It does.
So what is MCP and why has it become this lingua franca for AI dev tools?
So MCP, or the multi-context protocol, has become the standard because it basically solves the agency problem. And LLM on its own is just text completion.
Right. It's just a brain in a jar.
Brain in a jar. Perfect. To be a real agent, it needs eyes and hands in the real world. MCP acts like a central router for the LLM. It's an extensible tool ecosystem that standardizes how the agent queries the file system, runs shell commands, accesses a database, or calls an external API. It's what gives the LLM the ability to do things.
So it's the instruction set for how the LLM interacts with its environment. Otherwise, it's just guessing how to run a command.
Exactly. It gives the agent a reliable, consistent set of tools it knows how to use project to project.
Okay, that makes sense. Finally, let's hit the third theme, speed and flow. Principle 6 is all about the iteration cycle and building trust.
Rapid feedback loops. Developers need to iterate on changes and see updates almost instantaneously. This is not optional anymore. It's the core delight of the new experience.
And build times are a huge part of that.
A huge part. We see entire projects in the industry dedicated just to reducing build time, because speed is the ultimate form of developer delight right now. But speed creates anxiety, so explainability has to be a first-class citizen.
Meaning, if the AI changes 100 lines of code, I need to know why right now.
Immediately, before you even think about committing that diff.
And Principle 7, this feels like it dictates the future. Agent workflows.
This is the shift to full autonomy for substantive tasks. It's the agent take-the-wheel approach becoming more and more common. But here's the critical nuance. The tool must support varied levels of human-in-the-loop involvement.
So it's not all or nothing.
Not at all. Sometimes the agent needs to pause and ask clarifying questions. That's a necessary check for production code. Other times, a developer might just say, go fast, figure it out, and rely on what you might call the YOLO approach for prototyping.
That tension speed versus correctness is the central dynamic of all software development. And now the AI tool is forcing us to codify how we want that managed.
Exactly. And that brings us to the practical application. The sources gave us a really fascinating look inside Warp's environment, where prompting an agent is the main thing you do.
You can still run URLs though, right?
Oh yeah, you can still run your regular terminal commands, but the default is dialogue.
And here is the real implication of all this. Agents need different profiles for different tasks. The sources gave us this fantastic case study using the exact same prompt, build an NFL predictor app, but running it through two totally different agent profiles.
The strategic agent versus the YOLO agent.
Exactly. The project involves scraping 10 years of data, processing it, and then predicting future wins.
Okay, so let's start with the strategic agent profile. This is the one you'd build for correctness and safety, where you want really high confidence in the output.
How is that one configured?
The settings were all about reasoning and safety. They paired GPT-5, which is known for its strong, deliberate logic, with Claude 4 Opus, which is great at generating these long, detailed step-by-step plans.
And the guardrails were tight, I assume?
Very tight. Creating plans was always allowed, but executing shell commands was set to always ask the user for permission.
So the agent can think for itself, but it needs permission to actually touch the operating system. What was the workflow like?
It was methodical, highly transparent. It started by asking the user clarifying questions, should I scrape schedules or player stats first? Should I store raw data locally or in a database?
Okay.
Once it got those answers, it generated this thorough 14-step plan. It included setting up the project structure, adding type safety with Pydantic, building validation layers. the whole 9 yards.
That sounds perfect for production code, but where did it break down?
The trade-off is that constant human engagement. It stalled about halfway through because it needed to configure URLs for NFL schedules. It specifically asked the user to manually set environment variables, and it gave 3 options. The user picked one, but the URLs the agent generated kept returning 404 errors.
Ah, so the real world got messy.
The real world got messy. The NFL data repository structure had changed, so the agent's plan was flawless, but the execution failed because of brittle, real-world data sources.
Okay, so now let's flip that. The YOLO agent profile. Maximum speed, minimum caution.
This profile had far fewer guardrails. Applying code, reading files, and this is key executing commands were all set to always allow.
And what about the planning?
Creating detailed plans was set to never. The agent was basically given free rein to skip steps and iterate aggressively.
Hold on. The YOLO agent skips detailed validation and test scaffolding. For an audience focused on production, doesn't that just sound like a fast path to technical debt and disaster?
It's a great question, and it gets to the core insight here. The justification isn't based on engineering purity, it's based on the business goal.
The goal dictates the tool.
Exactly. If you're just prototyping a feature for a pitch deck, or seeing if a dataset is even viable, speed is everything. If you're pushing a security patch to production, correctness is the only metric that matters.
So how did the YOLO agent succeed where the strategic one failed?
Well, its profile determined its strategy. Instead of getting bogged down with the schedules, which was the brittle part of the process, it just pivoted. It went directly to the player stats data, which happened to have stable, reliable URLs. It completely avoided the problem area on its first pass.
That's fascinating. It used its lack of constraints to make a high-level strategic decision that a human might have only made after hours of debugging.
Right. It produced a working data set of player performance and a final summary table really quickly. The strategic agent is for correctness, where every step is auditable. The YOLO agent is for what the source calls vibe coding.
Vibe coding, I like that.
You get results fast, but you acknowledge you're sacrificing structure, and you know you'll have cleanup work to do later.
This complexity, it really underscores the next major challenge, which is context. How do you keep an autonomous agent focused on a big, established project without it constantly hallucinating or going off the rails?
That is addressed through project rules, and specifically using a file the sources call warp.md. This file is effectively the project's living brain. It's AI onboarding guide.
So instead of re-explaining my setup in every single prompt,
You document it once, and the LLM always has that context appended to its instructions.
it's the LLM's long-term memory for the project. So how do you get started with that?
You run a command, init, in your project root, and it generates a starter warp.md file. It uses standard markdown headings to organize the context, so it's easy for humans to read and for the LLM to parse.
And what kind of information should you be putting in there to make it effective?
You include clear headings for common commands, like npm run dev or npm run build, so the agent knows how to run and build your project. Then you provide a thorough architecture overview.
An architecture overview, like what?
The sources gave an example of including flow diagrams, component diagrams, and specifics like the front end uses Astro, the back end is serverless API routes, the database is Firebase, and we deploy on Vercel. It's like giving your new agent a full readme and an engineering spec on day one.
That's a huge amount of context. It feels like that file could easily balloon and become this massive, unusable thing that just slows everything down.
And you've just hit the most important best practice. Keep it lean, keep it intentional. Everything in your warp.md file gets prepended to the prompt. Eating into your token budget. Eating into your token budget. Making every single request more computationally expensive and therefore slower. Only include what truly matters for the task at hand.
What's the second tip for managing this with a team?
Treat it as a living document. The boilerplate is just a start. The real value comes from iterating on it. You should add your team's specific Git workflow preferences, like always branch off main, use descriptive names, squash on merge. The goal is for the agent to eventually code exactly like your senior developers do.
And for massive monorepos, which so many large organizations have.
Directory-specific rules. That's essential. You don't cram everything into one root document. You can go into a specific subdirectory, run init again, and generate a warp.md file tailored to that one subsystem.
Okay, so you avoid overwhelming the LLM with context from totally unrelated parts of the project.
Exactly.
And finally, how do you keep these files optimized?
You need to optimize your rules file. If your warp.md is getting huge, say over 500 lines, you should run it through a prompt optimizer tool. This helps you catch duplication and remove overlapping instructions to keep it efficient.
So when you step back and look at all this, what does it mean? The paradigm shift isn't just about writing code faster.
Not at all.
It's about shifting from writing code to
Right.
managing agent intention,
Oh.
setting up the right context and guardrails.
That's it. And if we connect this to the bigger picture, the sources raise some really interesting open questions about the future ecosystem. This shift could lead to massive consolidation. Will we see all these point solutions, fragmented tools for code review, app building, monitoring? Will they all collapse into a single, all-in-one AI platform?
And what about the interface itself? How will that evolve?
Will the AI IDEs we have today just become AI terminals? And then maybe something even simpler like AI browser replets, where your whole dev environment is just a big chat box with tools.
The standard development environment could become unrecognizable pretty soon.
Very soon.
And then there's the question of standardization. We're in this fragmented world right now of custom rules files, right? The sources mention things like .cursor rules or clude.md. That seems completely unsustainable.
It's absolutely unsustainable for any kind of large-scale enterprise adoption. We need a universal standard for personalizing these agents that isn't tied to one vendor. The source suggests that a file, maybe called agents.md, is a critical first step toward a cohesive, industry-wide system.
So, considering the trade-offs we just analyzed between the strategic agent and the YOLO agent, here is a final provocative thought for you to mull over. Developer teams have always managed this tension between speed and correctness, but now that the AI offers these two fully automated profiles, how will developer leadership define the right default agent profile for their own production environments? How will they, in effect, code their company's risk tolerance directly into their tools?